Alright, so what we're going to do is review the 2003 AP Calculus AB test, number 6 in the free response. No calculator section. Alright, and it says let the f be the function defined by the piecewise function radical of x plus 1 from 0 to 3, and the line negative x plus 5 is the way I would say it, from 3 to 5. And it says, is f continuous at x equals 3? Explain why or why not. All right, maybe I would start with a graph. I don't really have to. What I can do is I can take the limit as x approaches 3 from the negative side. And if I'm coming from the negative side, I have to be on the lower function. If I put that in there, I find that that's 2. If I take the limit as x approaches 3 from the positive side of f of x, I have to use the upper limit. The left hand and the right hand limits are the same, thus this is a continuous function. So I would say yes, left hand and right hand limits are the same. And I would make sure I wrote those limits I just put there, thus continuous. All right, let's see if Mr. Anderson scores all right. And I would spell the word continuous, but I'm lazy. All right, so today, answer yes and equate the left hand and right hand limits. All right, that's a point. So give yourself a point for this answer. The explanation involves limits. So if you just showed the graph, you know, and you don't get any points. You have to use the limits. You have to explain this through calculus. So just showing the graph, which the graph of this thing would look like what? If I did it over here really small. I don't need it, I don't think, for any of the problems. It's a radical. It's shifted here. At 3 it's 2. So here's the radical, and then it's 5 minus x, 4, 5. Yeah, it looks like this. I graph it, and it doesn't go from -1, so I have to erase. Yeah, you have to erase that. I just needed that to set it. So that is what's there, but listen, that doesn't prove anything. You have to have this. So these are the 2 points, and this is letter A. And it only writes flat if I change the color. So there's letter A. All right, 2 points. So score it right now. I'll group this and. All right, letter B. Find the average value of f of x on the closed interval of 0 to 5. All right, now this is a case of we should remember that f average, and again, if you want the formula, which I hate, you know, it's this, right? The way to think of it is it's taking the area under the curve, and you want the average for the area under the curve. You want to get the average here over across. So what you got to see on the graph here is you got to do this as 2 differentials. You can't do it as 1. And maybe if you have a really good graph, you could do this in terms of rectangles and triangles. But I'm not going to. So I don't think I'd even need to write this, but I probably would. So I have this. That's the average function. I'll put it up here. All right. I don't think it'll be a score. I would start at the top of my paper. First thing I would write, okay, I would write 1 5 minus 0 times. And I would have to make this graph myself. So this graph would be on my paper at this point. Because I would want to go from 0 to 3 of x plus 1 dx plus the integral from 3 to 5 of 5 minus x dx. And I would think to myself, have I found the area under the curve in the parentheses? I think the answer is yes, I have. All right. So now I got to actually do the work. So I get 1/5 x plus 1 to the 3/2. Hopefully I'm not making a math mistake, because again, I'm doing this just like you would, all right? And we'll score it. I think this is correct. I would write this then, and again, I make sure I try to leave lots of space. So 3 plus 1 to the 3/2 minus 0 plus 1 to the 3/2 plus 5 times 5. If I had to at this point, I'd erase, do whatever I got to do to make it all fit. 5 times 5 minus 5 squared over 2. That's the first one. I don't need that last parenthesis. 5 squared over 2 minus 5 times 3 minus 3 squared over 2. There. Oh. All right. Now here I go. 1/5 of, and this is where I just don't want to make a math mistake. You know what I mean? I worked pretty hard to get here. So hopefully I'm correct. I haven't made a math mistake yet. Okay, 4 to the half here is 2. 2 cubed is 8 minus 1 plus 25 minus 15. I would write plus 10. All right, 12 and a half minus 4 and a half would be 8, right? So it's minus 8. And I get a fraction. Hopefully I did this. I get a feeling for some reason I did this wrong. I get the feeling for some reason I have a math mistake, and I might have to go back through and check. So, and maybe I would rewrite the 2 at this point as 6/3. So I get 20/3 times 1/5. So 4/3. Now, for the sake of time on the video and everything, I'll go with zoom full entire screen. I'm going to score it as it is. We'll see if I made a math mistake. I feel like I made a math mistake. They might see it.
Can you please the so it says find the average value of the x close to that just doesn't seem like
What did you?
It's like the average y value.
Well, that is the average y value. Yeah.
So the average area is the average y value.
Yes. Yes. When it says the average value of a function, it is this every single time. All right. Well, let's score it. I'll tell you what. Let's go through it. 4/3 is the answer. Oh, Mr. Harrison didn't make a math mistake. Evaluation and answer is a point. So if you got 4/3, give yourself a point. So let's go back to the top. They're looking for the format that you had some number out here for an average. So they called it K, and that you had this integral right here. All right. So if you have some number times this integral, give yourself a point. Then they want, if you did the antiderivative of this square root of x plus 1 correctly somewhere on your page, anywhere, give yourself a point for this. If you did the antiderivative of 5 minus x correctly somewhere on your answer, give yourself a point. This was worth 4 points. The format at the top, the 2 antiderivatives, and the 4/3. But did you get some of the points on the top? This is why you have to write out all the steps, guys.
Average y value, and average value of y, and average area.
This is not the average value. This is not the average area. This is the, what we just found is, okay, let's be clear. If I put 4/3 up on this graph, I'm going to go back to 100%. We all agree the answer is 4/3. Mr. Harrison didn't make a mistake. 4/3. If I graph it up here, let's see, it was 1, it goes to 2, 4/3. Oh, shit. The board's off. It should be higher than that. There. The area under the red curve and the area under the green curve are the same. y equals 4/3 is the average of f of x. Get it? Because the area underneath the both of them are the same. Okay? Yep. I want the same area under my one value of y as is under the curve. So I find the area, and I divide by the run. Okay? All right.
So why is it plus? Why is it integral?
Plus the integral?
Yeah.
Because I need to add the area of this section and this section. All right. Any other questions? Those are good. Keep them coming. All right. I'm going to pause the video, shrink down this answer, and then we're going to go to letter C. All right. So I shrunk down letter B, stuck to the side. So letter C. So now think about it. We awarded 2 points for problem A, letter A. We awarded 4 points for letter B. How many points are left? 3. There's 9 points a problem total for the number 6. So we've awarded 6, so I know this is worth 3. It says suppose the function g is defined by g of x equals k times x squared of x plus 1 and then mx plus 2. So it's kind of the same thing. You have a multiplier on the radical, okay, which was just stretch this, right? Up or down. Remember, the multiplier just makes it bigger or smaller. And now we got mx plus 2. So if it's a negative slope, it's just going to adjust the slope of this line section here, right? If it's a positive slope, it's going to do something like this, all right? From a graph standpoint, we can kind of picture what's going on. All right, that said, I don't even know if that's really that important. It says k and m are constants, so what's the derivative of k? 0. What's the derivative of m? 0. They're numbers, so k and m are constants. It says g is differentiable at x equals 3. What are the values? 2 things. 1, if it's differentiable on a piecewise function, the derivative of each of these has to be the same at 3. If it's differentiable at a point, it is continuous at a point. So my blanket statement immediately is the limit as x approaches 3 from the negative side of g of x has to equal the limit as x approaches 3 from the positive side of g of x. So I can write, based on just this statement, that k times 3 plus 1, left-hand limit, equals m times 3 plus 2. All right, does everybody see this as 2 square root of 4 is 2? So I can write 2k equals 3m plus 2. And that is because, it doesn't say justify, does it? If it said justify, you'd have to write a reason here, a sentence that says, if the function is differentiable at 3, it's continuous at 3. I don't have to do that this time, okay? I might, though, just write because continuous at 3, since differentiable. You know what I mean? That's what's happening. I don't think I have to write it, but I'll write it anyway. Okay, one equation, 2 unknowns. I got to come up with another equation. I'm going to write that g prime of x. If it's differentiable at 3, we know the 2 parts are the same. So I'm going to write g prime of x equals. And this is where, guys, you really got to keep fractioning derivatives. You should be able to look at this derivative up here, at least the bottom one. What's the derivative of mx plus 2? M, slope. That's from 3, oops, not equal, 3 to 5. It sure helps if you can do this one directly, and maybe you do it over on a piece of scratch paper, okay? I get 1/2 k x plus 1, the derivative of x plus 1 is 1, so I don't have to worry about to the negative half. And I would write 0 to 3. All right, and I probably wouldn't fill my AP page with it, but I would write this. And then I jump off again. I can set these two equal at 3. So I would write 1/2 k, 3 plus 1 to the negative half, equals m. Oh, how pretty is that? And do we agree this is 1/2? So I think we get 1/4 k equals m. All right. And I cheated here. I just looked at the answer sheet. So I'm feeling real good. So now I can find m and k. Is that the only thing I was asked to do? I got to go back up. Yeah, what are the values of m and k? So I have this equation and this equation. I might even draw lines at them so I pull them together. I would substitute. I would write 2k equals 3 times 1/4 k plus 2. I can see that this is 3/4 k. Subtract 3/4 k, so I would probably write 1 1/4 k equals 2. Divide by 1 1/4, which I know is 5/4, right? So I would multiply by 4/5. And I would get k is 8/5. And I feel really good about that answer. And now I would come over here and I would say m is equal to 1/4 times 8/5. So I would get m is 2/5. Doesn't say justify. That's the answer I have. It's going to an entire page view. Let's score it. Dun, dun, dun. Here Mr. Harrison goes. Oh, I even put a line by it. You had that equation written. It says 2k equals 3m plus 2 is a point. It says k over 4 equals m as a point. Now listen, let's be clear. I'm getting the point because it's the same. This is where AP testers use their brain. And then finally the values. 8/5 and 2/5. And Mr. Anderson managed to do this whole problem without any math mistakes. I get 9 for 9. All right? Again, this is the problem. At this point, early in our AP review, for sure, I would sure hope you got 5. All right? I would actually hope for 7. But anyway, I'll close this. Tabitha, good luck. And if it's future years, good luck to all my other students.